Hello, and welcome to Classic Killer Sudoku, Episode 1. Now, you'll see that here we've got a page from 2009, January 2009, and you'll see this puzzle on screen, difficulty 9 out of 10. I gave it a go last night and managed to solve it, and I had quite a good time. I'm covering it up on my screen with my hand at the moment, because I'd like to give it another go. I don't remember any details from solving it last night, but I quite enjoyed it, so I thought I'd give it another go. So we'll go to start again here. I can't see what any of the numbers are. Alright, let's do this. I remember there being a lot of 2-cell combinations that we found using cage integration, like this non-net here. 35 plus 18 is 53, plus 5 is 58, which is a difference of 13 from 45. So what I do is I write in, if possible, I write in the difference and put a question mark on it. Same with this non-net, 30, 40, 54, which leaves a difference of 9. This non-net, we can work out this cell. 13, 32, 42, it's 3. And same on the other side, this seems to be somewhat symmetrical. 15, 25, 37 leaves 8. So this adds to 13. Okay, we'll look down here now. And we can work out what these two are. Or what they add to, at least. So 21, 32, 58. So they also add to 13, like up here. And same on the other side, 11, 25, 48. So that adds to 3. Okay, so we know for this pair that the only combination can be 1 and 2. Which means that these 3 add to 20, which limits the possible combinations. Looking at this pair, this cage here, 12, can't be 3 and 9, can't be 4 and 8, must be 5 and 7. Okay, looking up here again, for a cage of 5, the only possible digits are 1, 2, 3, and 4. And the only digit which can also go into a 13 is 4. 1, 2, and 3 can't go in a pair of 13, which means that must be 4, which makes this 9 and this 1. Which is good to know. So there's 15, can't be 6 and 9, the only other possible combination is 7 and 8. I'm looking for other possible cage integration now. Well, actually, looking at this pair of squares, which we know have to add to 9, can't be 1 and 8, can't be 2 and 7, and it can't be 4 and 5, which only leaves 3 and 6. And this 10 cage here, it has to be either 4 or 7, so we could write 4 and 7 there, but we know that there's a 4 there already, so it must be 7, which means this digit must be 3, and that's 6, and that must be 8, so that must be 7. Alright. Looking at this, we know this pair of squares has to add up to 13, so we can work out what the 2 digits are, because it can't be 6 and 7, it can't be 5 and 8, so it must be 4 and 9. I believe that will help us here as well. These 2 digits must add to... perhaps not though. These 2 digits must add to 10. It can't be 9 and 1. Can't be 3 and 7. Can't be 4 and 6, which means it must be 2 and 8. And because there's an 8 here, that digit must be 2. That must be 8. Now this 7 cage can't be 4 and 3. Can't be 2 and 5. Must be 1 and 6. This 13 pair can't be 9 and 4, can't be 5 and 8, must be 6 and 7. And therefore, in this nonet, the middle one, the 7 can only go in this square because it's taken here and here. In this nonet, the last 2 digits must be 1, 2 and 5. 1 and 2 are taken in this column, so that must be 5. The 1 is taken in this column, so that must be 2, and 1 goes there. We know that 3 and 5 are the only digits remaining there. The only digit remaining to be filled in this column is 8. The only options for this cell are 3 and 5, and for this column the digits remaining are 3, 4, 5 and 9. So we'll write that down. Can't work that out immediately, but that's alright. Alright, let's see what else we can do now. Okay, since not sure if this will give us anything, but we can try anyway. Because there's a 6 here, that means 6 can't go in the rest of the cells which are in that, which make up that cage, which is all the ones here. And that means the 6 must go in this 14 cage. So that leaves 8 left over, and if it can't be 6 and 2, and the other options are 7 and 1 and 3 and 5. Now 1 is taken up in both of these rows, which means it can't be 7 and 1. So these 3 cells must be 3, 5 and 6. And 5 takes up this row, so it can't be there or there, which means that must be 5. And that means that's 7, that's 5 there. this row, we've got 1, 4, 6, and 9 left over. Unfortunately, 1 and 9 and 4 and 6 both add up to 10, so we can't rule anything out there just yet. Looking at the second row, digits remaining are 2, 6, and 9. So we can at least write in 2, 6, 2, 6, 9, and the 6 taken there, so 2 and 9.
You're on SBS Chill.
Looking at this 13 cage here, because of the options that we have for this 10 cage, either 4 and 6 or 1 and 9, we know that this cage can't be 4 and 9 because that would leave 1 and 6 to make up 10, which is impossible, of course. So the other options are 5 and 8 or 6 and 7. In this particular cage, 5 and 7 are taken, so the options are 6 and 8, and that leaves for this square 5 and 7. Looking at this 15 cage, which contains these 4 cells, because the 8 and 7, well, the 8 and 7 being there mean that 2 and 3 can't go in this 10, so they must be part of this 5. The only thing from that is that 3 can't be in, 3 must be in the middle row. No steps forward there, unfortunately. I'm looking at row 2 again. We know that the 9 must be in this cage of 18. So I'm imagining if there was 9 in this cell, the only digits remaining to make up these two cells, because of what's already taken in this row, could be 4, 7, and 8. If the 9 was there, that would leave these two cells to add up to 9, and there's no way to get 9 from 4, 7, and 8. So therefore, this cell can't be 9, which means that that cell must be 9. Okay, that's good, because that means that the 9 can't, or this 10 must consist of 4 and 6. And these 4, well, these will be 1, 2, and 9, and these will be 1, 2, 3, and 9. Looking at this nonet, the remaining digits are 1, 2, 4, and 8. This particular cell has 1, 2, and 4 taken, which means it must be 8. So remaining up here are 1, 2, and 4, except 4 can't be there. So column 9, the remaining digits are 1, 2, 3, and 7. 1 and 2 are taken in this cage, so there must be 3 or 7. I can't see us getting any further than that at the moment. Row 3, we've got the digits 4, 7, and 9 left over. 9 can't go there, which means that these will be 4, 7, and 9. If this cell was a 2, that would leave 16, which can be done by 7 and 9. If it was a 6 though, that would leave 12, which can't be made using these digits we've got here, which means that this cell must be a 2, which makes that 6, that 8, that 5, and we know that these must add up to 16, which means it can't be 4, so the 4 goes there. That can no longer be a 4 or a 6, which means that we know that these two must be 1 and 9, which leaves 2, 4, 6, and 7 remaining for these 4 cells. So, 4 and 6, 2, 4, 6, 4, 6, 7, and 2, 4, 6, 7. Right, the first nonet, the remaining digits are 3, 5, and 8. 5 and 8 are taken here, so that's 3, and these two will be 5 and 8. Looking at row 4, these two particular cells are both 4 and 6, which rule out 4 and 6 for any other cells, which means that must be 2. Therefore, that can't be 2, and 2 cannot go here or here. So these are 1 and 9, which means that these two cells must be 2 and 3. Using similar logic, these 3 cells in the next row down are 4, 6, and 7, which means we can rule out 4, 6, and 7 for any other cages. for any other cells rather in the row, which means that can't be 6, which makes it 6. That can't be 4, and yes, that looks to be all we can do there for the moment. It's alright, we're making good progress. I suppose looking at this 11 cage, 7 and 4 and 3 and 8 will be taken, so the only possible options are 2 and 9 and 5 and 6. So we can write in 2, 5, 6, 9 there. And on this side, 2 and 9 and 3 and 8 are taken, which leaves 4 and 7 and 5 and 6. I would like to know I would like to know, considering that these two cells are add up to 3, which leaves 20 for these 3. If that was a 3, that would leave 17, which would make these two cells 9 and 8. This 7 would therefore have to go in one of these two cells. So if 7 was there, that would be 7 left over, so the only possible combination for cells within these 4 would be 1, 2, 4, and 7. Let's imagine that we have 1, 2, 4, and 7 there. I'll just put a question mark on it because we're hypothesizing at the moment. That would be 3, which would make these 9 and 8. So that would have to be 9. That would be 8. These two cells would have to be 5 and 6 because the 9 is taken there. Okay, so we can see that works. It uses all 9 digits without contradictions here, I believe. Now, what if it were the other way? Let's imagine this is 7. these two cells would add up to what we had before was 2, 5, 6, and 9. These were clear. So these two cells would add up to 13. Couldn't be 7 and 6. So it would be either 5 and 8 or 4 and 9.
SBS Chill.
Unfortunately, I don't think that's actually going to help us at the moment. We won't be able to get anywhere using that. Well, in that case, I was quite happy with how we worked this out before, imagining that this cell was 3. So if we restore this non-it to the way we had it, that 9, that 8, and we'll just put question marks on these for the moment. These will be 1, 2, 4. These 1, 2, 7 because of the 4 there. Looking elsewhere in these columns, that would have to be 9, 9. That would be 3. That would be 6. It is of course possible that I'm missing a particular combination somewhere around here, which would allow us to deduce more cells for certain. Actually, looking at this column here and this 11, if that was 4 and 7, 7 would be taken there, which means that the 7 would have to go there for that non-add. But also, the 7 in this non-add would have to go there, which is not possible. So we can rule out 4 and 7 for those. That can't be 6. It can't be 5. Oops. Does that give us any more information? This column only options are 4, 7, and 9, but the 7 is taken there, so that was 4 and 9. looking at this cage, the 26 cage, 6 and 7 add to 13, which would make these two squares. 13. If that was 9, 1 and 3 would have to go in these two, which is possible. And if that was 4, that would leave 9 left over. It couldn't be 4 and 5, couldn't be 3 and 6. It couldn't be 2 and 7, so it would have to be 1 and 8. Okay, this is good because we've worked out that if that's 9, these two would be 1 and 3. If it's 4, these two would be 1 and 8, which means that 1 can't go in this cell. Yes, these were uncertain, so I'll just restore what we had before. I'll try and remember. In case we can get any further now.
Taking you to Portugal with this track.
If looking at the 23 cage, we know that these 3 cells add to 20. So if that was 7, there would be 13 left over for these 2 cells. It couldn't be 6 and 7, and I believe it couldn't be 4 and 9, because for this particular cell, the only options are 4 and 9. Which means that these cells would have to be 5 and 8. And if that were a 3, we know that because the only combination possible for 17 is 8 and 9. So we know that an 8 must go in one of these 2 cells, but it can't be in this cell. So we know an 8 has to go there. So this cell will either be 9 or 5. And we worked out before that if this cell was a 4, the only combination for these 2 would be 1 and 8. But because there's an 8 there, it can't be, which means that can't be 4, so it's a 9. The only combination possible for these 2 now to make the 26 is 1 and 3. 3 is taken in this column. So there's 1, 3, that must be 9, that 1, that must be 7, that must be 4, can't be 4, can't be 4, that must be 7, that must be 9. Let's see, this column, the remaining digits are 4 and 8, 8 is taken there, so that must be 4, 8, and 2 and 7 left over for here. That can't be 9 or 3, that must be 5, so that must be 4, can't be 4, can't be 4. Okay, so we know that this 11 must be 2 and 9 because of the 5 there. So we know that this must be 3, that 2, this 1 because of the 4 there, 6, 4. That must be, because of 3 there, must be 7, must be 6, 7, that must be 2, 7, that must be 9, 2, that must be 1, 9, that can't be 1 or 2, so it's 4, and this can't be 3, so 6, 3, that cannot be 4, but it also cannot be 2, so it's a 1, that's a 2. That leaves 1 and 3 left over for these cells. 1 is there, so there's 3, 1, and 4 and 6 left over. That's a 4 there, so 6 and 4. That must be 5, that must be 6, can't be 5, can't be 5. This cell must be 5, and this cell, the only other option is 9. Leaving 5 to here, and 3. 36 minutes and 49 seconds. Whew. Well, we made it. Thank you for watching. I'll catch you soon for another classic killer Sudoku.